Hey everyone, welcome to the workshop. It's going to be a workshop because we're going to do mostly hands-on on how to build to Cosmos. So let me first introduce myself. Did it work? Yeah. So my name is Sean. Originally, I'm a developer for many years. For the past 5 years, I've been crypto enthusiastic. Worked in Fireblocks before, and now I'm working at Lava, a startup. We're quite young, and we're doing decentralized marketplace for Web3 APIs. But the interesting part is that we're building it on top of Cosmos. So we made our own chain, our own layer 1 chain. And that's what I'm going to talk about. We're going to talk about Cosmos. If you want to connect with me, Twitter, LinkedIn, or get a link to the snippets I'm going to show you here, then it's in the webpage, seana.com. How many of you here are familiar with blockchain? Please raise your hand. Thank you. How many of you are familiar with EVM Ethereum development? Perfect. And how many of you are familiar with Cosmos development? Nice. Okay. So the agenda, quite clear. We're going to quickly go over what is Cosmos. We're going to talk about architecture, but mostly to present what's the difference between Cosmos and Ethereum, because I know that's the interesting part. And then we're going to open up computers and ask questions. Everything here is open source. Nothing is proprietary. I stole all the diagrams for the Cosmos website. I hope they'll forgive me. Yeah, let's get going. We'll have in the end time for question, but if there is something urgent, then just stop me. Okay, so an exploding title. Cosmos is a decentralized network. Parallel blockchains, consensus, entanglement, you're going to hear that a lot. So basically, you know what a blockchain is, but for this purpose, let's rephrase blockchain and call it a state machine. Okay, because that's how, as developers, we're going to approach development to Cosmos. We need to understand that basically a blockchain is a fancy word. It holds a state, for example, a token balance. And from every block, this state may change, as we know, with transactions, for example. Another two aspects worth mentioning, which will help us. First of all, the blockchain is deterministic, meaning that if we'll take the genesis block and rebuild it incrementally, block after block, we will have the same state for all of the different nodes. And another key part of blockchain is the consensus. So we all know consensus. For example, Ethereum moved from proof of work consensus to proof of stake consensus. Cosmos is a proof of stake consensus. And we'll see that we have part of that as developers. Okay, so not all blockchains are built the same. There's a few big differences. Let's go over them quite quickly. Hold on. Okay, so what is the architecture? So what is the basic blockchain architecture? And if you have done Ethereum, then you've mostly worked here in the application layer. So the entirety of the architecture is three main parts, but the consensus is the part where we have some validators, for example, who get new blocks, and they're responsible in affirming that the blocks are correct, sign them, and then move them on through the network. And the application is essentially the state machine. So it's the bunch of code that's being replicated from block to block. And if the validators are the one to sign the actual content, so the networking is the layer that helps move the data between all the participants. So let's see how does this reflect in the world of Bitcoin and Ethereum. So Bitcoin, if I'll go back to here, is one big mush of all the three together. If you want to build on Bitcoin, you can't really do something just on the application layer. Now that's not entirely correct. It has a scripting language, but I'm guessing none of you have developed anything for Bitcoin. For Bitcoin, if you want to do something on the application layer, you'll probably fork the entire stack and then have like a replica of the entire stack together. That's like Dogecoin or other infamous blockchains. Now, the need for working just with the application layer and starting to build things came with Ethereum, and that was the first blockchain, we can call it version 2, that allowed you to plug in to the application layer. Now, with the rise of Ethereum, there were a few issues that's worth mentioning that will bring us to the version 3, which I'll do a spoiler, and that's going to be Cosmos. So limitation number 1 is scalability. So in terms of scalability, so it's a giant, and it moves slowly. How many transactions can Ethereum can process in a single second, per second, TPS? 15, right? Okay, so I have it also written here, 15. I haven't checked if after the consensus change it has changed, probably not. But 15 transactions per second. How much can a Visa, MasterCard can? A lot more. So we all know, we all live in a world of everyone are trying to do the next layer 1 sidechain in order to fix that problem. And we see many solutions trying to come up with that. Limitation number 2 of Ethereum is usability. Let's talk about usability as developers. So as developers, we're all, if you're building an EVM application, then you're constrained to what I call the common denominator, מכנה משותף, נמוך. So you have like, you're constrained to do only what is inside the sandbox of Ethereum. And yes, it's rich. It's a rich language. You can do whatever, you can do a lot of things that you want, but you can't do everything. You're still constrained. And it's basically, you need to optimize for the average use case. And you're constrained to one programming language, Solidity. And the third limitation of Ethereum is that you're building the app, but you have no control over the layers beneath. So it means two things. It means in terms of modifiability, that's not a word in English, but you can't modify the consensus to fit your application if you need. If there is any bugs or limitation you want to patch in the consensus, you can. And also, it's a kind of the data itself, or the sovereignty of the data itself, it's not under your control. Maybe I'll turn this one off. I'm not touching. So, okay, so now these limitations on version 2, they're not limited for Ethereum. We have many other chains, and we can see the same things there. And that brings us to version 3. So in version 3 of version 3, we can say Cosmos is version 3. And the purpose, what Cosmos tries to bring, I see it as two things. There's a lot of buzzwords, lots of stuff about Cosmos, but two things. One, it enables, instead of doing lots of silos L1s, that each one doesn't connect with the other one, you can build your own blockchain. And on the low level of the technology, you get like rich connectivity between the blockchains. So let's say from another world, Ethereum, Avalanche, and BSC. Between them, there is no like interoperability. You can't really make bridges on the level of like the low level of the frameworks. So this is one thing Cosmos is trying to solve. The other important thing about Cosmos is its modularity, and the fact that it's like Legos. You can build Lego out of a lot of the stuff, and the important stuff about it is that most Legos are already built, okay? So you don't have to invent the wheel again. And when you want to build another component, another model of your app-specific, your business case, then you don't need to reinvent the wheel. You just need to add the model of your choice, and it sits as a part of the models. You can look at it as a kind of a D-app, but it's a module within all. And once we have this module approach, then blockchains can connect, can talk between them. That's with mostly what we call IBC. And okay, so a quick overview. I see I have time. We started a bit early. A quick overview of the modules. IBC, inter-blockchain communication. It's a bridge in the low level that helps connect data, helps you move assets between chains. Governance is how you control changes to the protocol. Staking, slashing, about our validators. And you can see, if you're not colorblind, then there's a part here called ABCI, which technically it's an interface that connects the consensus to the actual application layer we see here. So this is an example of the bridges, how you can do bridging between, like a visual one. And if you'll go to the Cosmos website, you'll see like maybe a diagram with many models connected together. And we'll see that in our hands-on presentation. What else do we want to talk about here? Okay. One last thing. In the demonstration, we're going to use scaffolding. Okay, so the scaffolding, when we're going to scaffold a new chain, we're going to get automatically all the chains, all the models here together. Okay, we'll see that in the demo in a second. Okay, so we're one step before starting the demo itself. These are the pillars of developing for Cosmos. Okay. If you go to the GitHub of Cosmos, you'll find probably these. I want to tell you what are each and what are we going to focus on in a minute. So the Cosmos SDK is the actual implementation of the entire Cosmos protocol. That's going to be your main code that you're going to use. The Tendermint core is you will see it as Tendermint core or Ignite. They changed the name, but it's somewhere in the middle. That's where the consensus sits and the application interface. The Ignite CLI is the bunch of tools that will help you kickstart your app if it's scaffolding, for example. IBC is the bridges. Cosm, WASM is the smart contracting platform. And the Cosmos Hub is like a hub, an actual implementation that helps connect the blockchains. Now, I haven't mentioned the smart contracts on Cosmos. And now we're not going to touch that. We're going to touch the three levels of we've seen before of the architecture. Cosm WASM from WebAssembly naming allows us to build smart contracts on top of our blockchain. Okay, so it's a bit of a mindfuck if you're coming from Ethereum, but think about a quick example, and then we'll move on. Think about DYDX. So DYDX, they were a smart contract on Ethereum. Then they moved to some layer 2, right? But they were rich smart contracts, Empire. Now they're deciding to move to Cosmos, and that's one of the many reasons is to allow developers to build on top of them. So maybe in a year from now, you'll say, yeah, I'm a smart contract builder on top of a DYDX chain. Okay, and then they'll be able to offer more rich functionality for their developers. Okay, moving on to the presentation. I think I'll need to switch this. Okay, I'm going to show you the presentation. All the code samples are available here, tiny URL. Really short snippets that can help you kickstart. If you have a computer with you, you can actually do that while we speak. Not sure how's the internet here. Let's turn that off. Not sure how we turn it off. Just I'm afraid of the echo. But I'm taking this and just don't want the other one to echo. Ho, ho, ho. Okay, perfect. So, excuse me, but I need... Okay, so what we're gonna see in the presentation here are four group of steps. The first one is gonna be a setup. Actually, that one I'm not gonna go with you. You're gonna need to install Go. There's a snippet to do a hello world with Go, which is quite cool. You need to install Ignite. Ignite is our scaffolding tool. B, we're gonna create a vanilla chain. A chain that does nothing, but it's scaffolded entirely with no other change. Then we're gonna start add some code changes to our chain, make it ours, make it app specific as in the Cosmos terms. Then we're gonna access it externally through HTTP, through CLI. Whoops. And that's it. And then we'll have time for questions. Okay, so that tiny URL we saw just before will lead you to the panel on the left. Maybe we need a better zoom here. Hold on. Okay, we're gonna jump straight to the scaffolding part. Let's try like this. Scaffolding, vanilla chain. So we've created a directory. And we're gonna call ignite scaffold chain demo, and immediately we're gonna open that directory and open Visual Studio Code. So the name we call ignite scaffold chain is the operation, is the command we're gonna do. Demo is the name of the our chain. Let's give it another second. Perfect. So we have our chain code here. It's already baked in with git ignore, with first commit even. So what do we see here? And that's the directory structure explained. Main directories are the app. The app is where it's the glue of all the files together. You'll see lots of boilerplate code that goes in here. For example, all the models that we discussed, for example, governance or IBC, we can see them initialized here. In the proto, that's shorthand for protobuf, you'll see files that help us describe the data structure. It's really useful for the scaffolding, and we'll see that in a second. And X. So X, whenever you see an X, it's the models, our custom models. So already we're in X and we see demo. There's a module called demo, like the name of our blockchain. So we did that. Next step, let's run the chain. So okay, so we're doing ignite. Chain, serve, parameters. So we have -r is reset. We don't actually need it right now, but we'll need it a bit later. And -v is a verbose. We want to see what's happening. So version, protobuf is being calculated and built and it's now in the process of building the blockchain. And we have some Genesis scripting of the first blocks. We have generation of some access, we'll see in a second. And we have the ABC node starting. And we have blocks, okay? We have a Genesis block. That was one liner of code. That's amazing. Okay, so we have the blockchain running. It's printing the blocks. It has like basic info here. We're at block 28. I'm stopping the chain for now. And we now want to start customizing the chain, make it ours. So we're with the intention of creating a new model. Sorry. We're going to call Ignite Scaffold model the name of the model, and we already say that we want to have a dependency on the model called bank. The model bank is the one that handles the custody of all the funds, transaction like the basic settlement layer on Cosmos. So it created a bunch of files. You can see it under X, a new my mode, and a few of the different components that we won't really touch here, but I'll show some examples. So let's go back to our visual code and go to the new model. Amazing. So you see in green, because it's a new change, we see all the different files. And we'll visit some of them in a second. Some more changes we have in different directories, also marked in green. In protobuf, there is a new folder, and we'll see that also in a second. So we touched one of the scaffolding types that are available. There are many more you can use here. We created a list here for you to see. Now we're going to touch, okay, now we want to add an actual state, available state for the blockchain. Meaning we want to create some variable that will live, that his state will be replicated from block to block. So in this case, we're going to scaffold an entire list. And we're stating that it's going to be inside the module my mode. And we'll quickly explore that list. Okay. Okay, so there are a few components, before moving on, there are a few components that you'll see the naming appearing here again and again. So one of them is the keeper. I want to do a little order. So we have, basically the keeper is the set of classes that help us modify the state. It's the layer that sits on top of the state and help us modify if it's getters, setters, or some crude actions. We'll see it here. We have handlers that help decide how to handle the different messages from the blockchain. And we have messages. Messages sit inside the transaction. So we'll see the contents of some of them here. Okay. Let's jump for a second hold on. Okay, sorry for the small screen here. Let's make it a bit bigger. Okay. So we created the list. Automatically, we have getters and setters for this list already accounted for here. Now, it's the syntax of Go. Maybe if some of you were developing C, C++, it might resemble. But what we have here is a bunch of things to help us eventually access the data itself. So we see the context. The context is an object that helps you see the current state of the blockchain. So if you want to know the block height or the block contents, it will be from here. The KV store is the database of all the data that helps you connect to the different keys. And as we have the getter, we'll also have the setters. Okay, continuing on with our things here. So we have the part where we go to Protopath, and we want to add something to the new data type we just created. So instead of going, we saw there are a lot of classes being created. Instead of going to each one of them and update, we're going to the root of the specification of the class. That's Protobuf. And we're going to add this field, the extra 3. The extra is a name we chose. And the purpose of it is just for the demonstration, my list store, proto. So that's the definition of the current list store. And we're adding the extra field. Now, every change we're doing to the protobuf requires us to call ignite again and ask it to generate files again, because we want to see the change propagate. Okay, so that was generated. Let's go strictly ahead to message server under the keeper. The keeper are the files that, again, helps us access the state itself. So, okay, so we're in a creation of my list store. It's sort of inside the CRUD, that's the function that creates. And on the creation, we have a constructor, okay, like the good old days. In the constructor, we're gonna, if there's already one field that's called creator, the creator is simply the one who created the message, and we're gonna utilize, we're gonna take extra and give it the value of the current block header hash. Now, how do we do that? With the context we saw before. So the context should carry that data. Let's save everything, go back to our terminal. And now we'll need to restart the chain again. Here, in an actual use case where you develop a chain, you can just add state to a new block and then run it. For example, let's try that here. If I'm just doing serve for the chain, I'm expecting to see an issue. Now, we said early on that blockchains are deterministic, meaning meaning that we had our genesis blocks, and every action, every state that we want to change, the definition of the state, we need to incrementally get to it in order to have our chain viable. Think of it like ordinary databases. You can't just pull the latest data and build it from scratch. You need to make all the incremental upgrades. The same goes for here. If we are now in a real life scenario, we would need to let our entire network do like a soft fork into the new blocks. We'll need to create some script in order to help them with that, or a hard fork. But in our case, because we can, I'll just do a reset and start again from the Genesis block, avoiding any needed upgrades. Okay, perfect. Now we have the chain running. Now opening a new tab. Bigger. Okay, now there are two ways to access your chain. So we have demo D. Demo is the name of the chain. D is the CLI that helps us access everything. I forgot what's the name of the standard CLI, but it has all the commands. For example, you do demo Q, demo DQ, and it will help you query stuff. So I won't do the whole query, but we'll see here. Okay, we can query, for example, it says demo D query, command, where is my mode? My mode. Okay, so we're one by one we can construct our CLI command. In my mode, what can I do? Hop, we see our list, my list store. Now, the same thing here, if I'll query, if I want, I have through HTTP API spec, like Open API Swagger style. And if I look for my mode, it won't work. Right? Not sure. Maybe the search here. Anyhow, you can test all the APIs from here as well. Okay, so let's do query our new state, and we have a list. It's already on, but it's empty. Let's go to demo D and tell it create the list store. Now it says from Bob, so there's Bob and Alice. Bob and Alice are already pre-configured entities that lives inside our basic configuration file in the config YAML. They're already, one of them is validated already, and they have the Genesis tokens. That's like the tokenomics, the basic tokenomics of the Genesis block. So currently I'm signing as Bob. I'm creating a list store. Okay, I have a confirmation. Now I'll run again the same query, and this time I have the result here. So this is an example of how we started the chain from scratch, and then we're able to add data, run it again, change the data, and we saw some basic info on how to do stuff and where to start. Now I have time for one or two questions. Or even not one. How much time I have?
1 minute.
1 minute. Okay, hold on. Yes. Question from the crowd.
If I want to retrieve information from applications outside of my blockchain.
Retrieve information from application. Okay, that's going to be part of the IBC model. You'll need to implement it, and also connect the proxy connections between the networks you want to connect eventually to. As long as they're Cosmos, they're running Tendermint, and you will probably use a Cosmos hub for the hub for all the chains.
Thank you.
Sure, thank you. So I think that's all from questions. Myself and my great VP R&D are also here. Is here for questions later. Pleasure to see you all. Thank you.